Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to start a new video on mathematical statistics. So, this is going to be a new first chapter on sampling distribution. So, the objective of this chapter is to describe the sampling distribution, how to convert from normal distribution to others type of distribution, right? So we need before we start, we need to know some term that we're going to use in this topic is parameter, such as parameter. Parameter is a measure for population, and statistic is a measure for sample. And the purpose of sampling distribution of the statistic is actually a tool that tell us how close the statistic to the parameter, and the probability distribution for all possible value of a statistic that result when the random sample of size n are repeatedly drawn from the population. So without further ado, I'm going to discuss we're going to have nine theorem basically in this chapter. So I'm going to discuss first theorem is going it tell us let x1 x2 and xn be a random variable of size n from a normal distribution with mean equal to mu and variance equal to sigma squared. So it tells us xi having a normal distribution with mean equal to mu and variance equal to sigma squared. So if you want to find x bar, right? So x bar is equal to summation of xi n I equal to 1 until n divided by n is normally distributed with mean equal to mu and variance equal to sigma squared divided by n. So it tells us mean, say x bar, having a normal distribution with mean equal to mu and variance equal to sigma squared over n. So what is the theorem tell us is when you have a population, a set of population, right? Let's say many member in the population, so all member in the population. So let's say you take one sample, right? You measure the mean for that sample, right? Then you take another sample, you measure mean for that sample. You take another sample, you measure the mean, right? So sometimes the mean for first sample, this is a sample number 1, sample number 2, sample number 3. So sometimes mean for sample number 1 is not really reflecting the whole population. So if you want to see if you take 3 sample and then you do an average for that sample, right? So then you're going to get mu, same as the population, and variance should be sigma squared over n. So how to prove this formula is pretty easy actually. So we know that x is a normal distribution with mean equal to mu and variance equal to sigma squared. And then the expected of x is equal to mu and variance of x is equal to sigma squared. So now we want to find x bar. X bar is the expected of x bar is actually equal to summation of n 1 I equal to 1 until n xi. So to find expected of x bar is equal to 1 over n expected summation of xi until n, I equal to 1 until n. So this one should be equal to expected x1 plus expected x2 plus until expected xn. Right. So we know that expected of x is equal to mu. So then going to be 1 over n mu plus until the n mu, right? So there are no n here, right? But because this is a constant, right? So this one should be 1 over n multiplied with n mu. So this one should be equal to mu. So the first formula is proof. Now, if you want to find the variance, the formula, the theorem says that the variance is sigma squared over n. So to prove this, variance of x bar is equal to variance 1 over n summation of xi, where I equal to 1 until n. So the variance, once you take out the constant outside the variance, you should square the constant. 1 over n squared variance x1 plus variance x2 plus until variance xn, right? Okay, so it become 1 over n squared multiplied with n sigma squared, because the variance of x is equal to sigma squared, right? So now it become n sigma squared divided by n squared. So we can eliminate the n, the denominator n and denominator n should be equal to sigma squared divided by n. So we prove that when we have the variance sample x bar is going to be normal distribution with n mu equal to mean equal to mu and variance equal to sigma squared over n. So that's all. I'm going to continue next theorem on next video. So thank you. Bye bye. It's caught in the crossfire. It's caught in the crossfire.